Hi viewers, how are you? Hope you are doing good. In continuation to the video, in the playlist Basic Simulations Laboratory, here I am going to explain you about the rest of the windows in the Octave, and then we will see today how to work with Octave software with some basic operations on matrices. So in the last video, you can check the link of the last video in this description of this video, or if you are in the playlist, you can automatically see the first video in the playlist. On that day, in that video, I explained you how to work, how to install the software Octave. Then I explained you what are the different windows which are available in the software Octave, and we left with two more windows to learn that we will see today. So just to repeat, we have learned about Octave command window first, then I explained you what is documentation window, then I explained what is editor window. So these are the two important windows here, command window and editor window, which are cascaded and available in this portion of the Octave. So this is the complete window of the Octave. In this complete window of the Octave, this window which is giving you cascaded 4 windows in it. So there we have seen on the first video, what is the use of command window, what is the use of editor window, and then what is the use of documentation window also. So to summarize, command window will help us to issue some commands to the software Octave, and we can get some response from the software. Response in the sense, whatever the input we are giving to that, system will respond with an output. Say for example, I will write a is equal to 2. It will display a is equal to 2 on the console. See that. If I type b is equal to 2 or b is equal to 5, it will display b is equal to 5 on the terminal. So this window, command window, is also called as the terminal window, terminal, terminal window, or it is also called as console or a command window. So whatever the input we are giving, system will give a corresponding output immediately as soon as you type it. Say for example here, c is equal to a plus b. It will give us immediately the calculation of a plus b, and it will display the answer c is equal to 7. So that is about your command window. Whatever the commands you will issue, it will respond accordingly. Say for example, I want to clear the screen. Further, the command is clc. It will clear the screen. And if I want to learn about any command, we have a command called help. If I type help space command name, say for example clc, just now I used, it will display the complete information about what is this command clc is about, what is the use of this command clc. So system is taking time. Now you can see it's shown what is the use of a clc. clc is a inbuilt function from the file libintrp / so on so. It is an inbuilt command which is available in Octave. So this command, what it will do, it will clear the terminal screen and move the cursor to the upper left corner like this. If I type clc and press enter, you can see here it cleared the terminal and moved the cursor onto the upper left corner. So this command window will help us to check the output of all the programs which we are going to work with this Octave, and sometimes it will display the partial output in the command window and rest of the output maybe in a pop-up window, a figure like that. But the drawback is it will respond for every input. Like in the example just now we have seen, I want only c is equal to 7, the final answer. Input a is equal to 5, b is equal to 2. I don't want it to respond immediately. I don't want it to display it on the command window. So that is not possible in the command window. So we'll use editor window. Here we will write the program CLC, then we will write a is equal to 5. I don't want to display a is equal to 5. They will put a semicolon there. So the output will be terminated for that statement. Similarly, b is equal to 2, put a semicolon. So output will be terminated again for this b variable. And now c is equal to a plus b. It will display the output for this. So after typing the program in the editor, I repeat again, we have to save the file. So I told you on that day in the last video how to save the file. File name should not start with a number, it should start with an alphabet. So I will write it as second, and this second should not match with any keyword in the library. So it's better give a number to that. Second 123 dot m. If you don't give extension also, it will take automatically dot m. So second 123 have created, and I will save in my desired directory Hanuman. Click save. Now if you click this, save and run, this is the option available for save and run. Otherwise you can go to the file menu, you can click save first, then go to the run menu and then click save file and run. Our shortcut is F5. So if I click on this, you can see in the command window I got output only 7. This system is taking time to display the output. Let's run the program again. Save file and run. You see this time I got c is equal to 7. So it cleared the screen and it displayed the output, only current output c is equal to 7. So that is about your use of editor window. So whatever I did in the command window, same thing I am doing as a program. I am writing it as a complete program. This is called as a script. So we wrote a script for addition of two numbers. In the two inputs are variable a and variable b, and the output is c is equal to a plus b. So I want only the c is equal to a plus b to be displayed. So I didn't keep any semicolon here, and I kept semicolon for these two to terminate the long output for these two statements. So that is about the command window and editor window. A quick recap of the last video, what we have seen in the last video. And documentation window, as I told you, it will help us to learn about Octave in detail. You can learn about all the different topics which you are interested to learn about the Octave. And coming to this variable editor, this is not required for the time being, so we won't use this window. We want only this command window and editor window. Now coming to this file browser, as I already told you that while saving the file, we have to choose your specific directory. In that directory only we have to save the file and set that path here. C uses Hanuman, so that whatever the programs you wrote, that will be readily available here. You can access them in your while you are working with the software. Now coming to the one more window here, this is called workspace. This particular window, this area, so this is called workspace. The use of this workspace, you can see here, just now I used a is equal to 5, I saved b is equal to 2, and I asked the system to calculate c is equal to a plus b. So I got 7, but all those things are stored into the computer's memory with like a variable, it's a double type, its dimension is so and so, and a value which is stored in that memory is 5. Similarly b and similarly c. So this window, which is called as, we can call it as a workspace, or we can call it as a memory window, that is displaying you the data in the computer's memory, how it is stored, what type of variable we are using, and what is the value of the data. All those things will be shown in this window, and it's advisable to clear this window repeatedly for every new program. If you forget to do that, then the system may not give you outputs for long programs. I mean, for a program which is lengthier, system may not give you the output if the memory is not cleared regularly. So in order to clear the memory, the command is clear. Clear is the command to clear the memory window. See here, if I click clear and press enter, after clicking clear and press enter, you can see here memory window got cleared. Now if I write C is equal to A plus B, system don't know what is A and B, so it won't give you the output. You can see it is telling that I don't know what is A. So earlier it remembered because it is there in the computer's memory. So like if you do A is equal to 5 and B is equal to 2, if you write same C is equal to A plus B, now it will display it will give you the output because now A and B are there in the memory. So to clear that memory, command is clear. To clear the screen, command is CLC. And now if you try again C is equal to A plus B, it will give you error again. I don't know what is A because it is removed from the memory window. So system is showing that there is no data available and there is no variable with name A. So it is telling A undefined. I don't know what is A. So that is the use of your workspace. Now coming to one more window, we have a window here at the end on the extreme left on the downside. This is called command history window. Right from the day the Octave software is installed in the system up to now, it will record all the commands which we have issued. Just now I have issued CLC, C is equal to A plus B, clear, so on, so on, so. So it will maintain all the commands in the history. It will just tell us what are the different commands you have used recently or since from the day one, from the day when you install the software. So all the commands will be recorded here and you can see the command history here. So that is about all the different windows: file browser, workspace or memory window, command history, command window, editor window, documentation window. So this is about the Octave software, introduction to the Octave software and different windows which are there inside that, and some of the commands, basic commands, how to clear the command window, how to clear the memory window, like that we have seen. So sometimes this happens, like windows will get disturbed in your system, you cannot see some of the windows. So what we have to do is just go to the Windows tab and then go to the last option, reset default window layout. If you click on this reset default window layout, system will give you the default Windows layout right from the day one when you install the software. How it looks like, it will maintain all the windows to that reset position. So again you can see here file browser window, workspace window, command history window, command window, documentation window and editor window, and even the variable editor window which we are not using, so I am again deleting that. So these are the different commands and basic these are the different windows and the basic commands which we are using. So now let us see how to work with basic operations on the matrices, or how to work with some of the basic signals. So before that, let us see how to create a row vector with some elements inside that. So I want to create a row vector with the name A, with variable name A. So A is equal to, I want to create some row vector with some elements. So I have to take square bracket, 1 space, 2 space, 3, and close the square bracket again. So it has generated a row vector. Same thing can be done like this also. A is equal to 1, 2, 3. So it is not accepting, so we will take comma, 1 comma 2 comma 3. So it won't, still it is not accepting. It is telling answer A is equal to 1 answer is equal to 2, answer is equal to 3. So in order to create a row vector, always we have to use this. A is equal to square bracket of 1 comma 2 comma 3. But if you want to generate some elements from 1 to 3, same like this row vector 1 2 3 with 3 elements inside that, so we can use this type of command also. A is equal to 1 colon 3. Here I am not using any square bracket. You can observe it has generated the same 3 elements like in this case. So just to tell you or to make you clear that in order to create a row vector, we have to use square bracket and give the elements inside that, or otherwise use this command. A is equal to 1 colon 3. Starting element is 1, ending element is 3, and the default separator, I mean the repetition of the elements is interval is 1. Or otherwise you can create elements by using this command also. A is equal to square bracket of 1 colon 3. So I want to make only one point clear here, that if you want to create a row vector, use the square bracket and give the elements inside that. If there are more number of elements, if you want to generate 10 elements or 20 elements, 30 elements, this approach is not the correct one. We cannot type all the 30 elements. So just type A is equal to square bracket, the first element and then the last element, again square bracket here. You see here. So I want the first element is 1 and last element is 35. So I want all 35 elements as a one row vector. Like this, it will give you all the 35 elements in that row vector. Same can be given without square bracket also. Same output I am getting. So what is the final conclusion I want to make here is, row vector can be created by using this command. A is equal to square bracket of 1 space 2 space 3 or 1 comma 2 comma 3. All both approaches are correct. If you want to generate more number of elements, then use the starting element colon, like in our case previous example, ending element. So for this you need not give even square bracket also. That's what I want to make it clear. It is generating elements from first to the last without square bracket and with square bracket also. But if you want to create only with limited elements which you want to type, either you can use space between the elements, like A is equal to 1 space 2 space 3, or you can directly give in square bracket 1 comma 2 comma 3 also. So that is about how to create a row vector. Now how to create a column vector. So first create a row vector 1 comma 2 comma 3. I have created a column vector, I mean row vector. Then I want B to be column vector, that I will write B is equal to A dash. This will give us a column vector. So this is the column vector which we have created. Now I want to create numbers in such a way that the starting element should be 1 and the next element should repeat for every regular intervals of 2. So like I want 1, then 3, then 5, then 7, then 9, like that. So elements are repeating with separator as, that is regular interval as 2. So that can be given, that can be generated by issuing the command like this: 1 colon, the starting element is 1 colon, repetition. So every second element should be repeated. So give that number 2 there and then put colon, and then I will write 9 and press enter. You see here, first element is 1, it typed as it is, then it is repeating every second element after that. So after first we have second and third, so third is the second element. 4th and 5th, 5th is the second element, 6th and 7th, 7th is the second element, and like that it is repeating every second element. So if I remove this, what is happening here? In this case it is typing all the 9 elements, and what is the repetition or what is the recurrent interval here? It is 1. So by default it is like this, 1 colon 1 colon 9. You need not mention this 1, it will automatically take the separator as 1. So you see here, same output I got for 1 colon 9 and 1 colon 1 colon 9. So this 1 you need not mention, by default it will take automatically. So if you want the separator as 0.1, 1 colon 0.1 colon 9, now you see how many values I will get, 1, 1.1, 1.2, 1.3, so on up to 9. So like that you can create a row vector with desired elements. Starting element is what, and then what should be the repetition, every next element, subsequent element, how it should be. So that can be decided by this command. And there are some other commands like if you want to find out what is the 5th element in a particular row vector, that also you can do that, 2, 3, 4, 5, 6, 7. So this is a row vector I have. So if I write y is equal to a of 3, it will return the third element in that, first element, second element, and this is the third element. So like that this command a of 3 will give us the desired element from that row vector. So you can execute like this one by one by issuing the commands, or otherwise type it in a editor instead of calling one by one command and checking the output command wise. We can type it in an editor and we can work with that program also. So this is how just now we have seen generating a row vector, finding the particular element in the row vector, how to create how to get the values from 1 to 7 with separator of 2, and this is a row concatenation. 1 2 3 4 5 6 7 is the row we have, and B is again 1 2 3 4 5 6 7. If I write in square bracket of a comma b, 2 rows will get concatenated. I will get 14 elements in one row, and this is column concatenation. I will get 14 elements in one column. So I am going to get only one column, but with the two A and B are getting concatenated. And coming to the other arithmetic operations, like I want to perform matrix addition, subtraction, multiplication. So for that we have to generate a matrix first. We will generate a matrix like A is equal to first elements, that is first row 1 2 3, put a semicolon there, it will take second row, 2 space 2 space 2. I am using two different types of commands to create row vector and column vector, row vectors, to tell you just that system will accept both comma and space. So I got a row, 3 by 3 matrix. So if you want to perform matrix operations, you have to take two matrices of same size. So I will take B matrix is equal to A dash simply. So this is the B matrix. I have A matrix and I have B matrix. If you want to perform addition, simply write A plus B. This is matrix addition. If you want to perform multiplication, simply write A star B. So this is matrix multiplication. If you want to do element wise multiplication, that is first element in this matrix with the first element here. So element wise operations can be done by dot. So I want to do multiplication, so dot star I took. A dot star B, you observe here I got 1 4 3 4 4 4 3 4 9, but the multiplication was different. So in the multiplication we are multiplying all the row elements of this matrix with all the column elements of this matrix. Multiply and sum we are doing there. So I got 14, but in this case with the dot star instead of star, I got 1 into 1 is 1, 2 into 2 is 4, 3 into 1 is 3, like that. So like that you can perform matrix operations like addition, subtraction, multiplication, division. So same thing, instead of giving commands one by one there, I typed it here itself in the program. So let me explain quickly the program which I wrote for the third category. This is sorting operations. It will sort the elements in descending order, ascending order, whatever we want. Like I have a row vector 37854. If I say sort a comma descent, we will put numbers in descending order. So we will check that, only one we will check in this. So copy this here and paste it here. You see here. So after giving the command sort a comma descend, numbers became in descending order 87543. If you write ascend, A, C and A ascend, sort of a comma ascend, then you see numbers are in ascending order. If you want A dash and ascend, A dash is nothing but row vector will become column vector, and then elements are in ascending order. If you want in descending order, then write DS, descending, numbers are in descending order. So like that is very simple. These are sorting operations, and these are all array power operations. Just now I told you dot indicates it's element wise, so I want to perform element wise square operations. This is element wise multiplication operations. Then sum of A will give it will just add all the elements in that row vector. And these are the different commands. I will give us identity matrix, ones will give us ones matrix, zeros will give us zeros matrix, and then diag will give us a diagonal matrix, magic will give us magic square matrix, random will give us random matrix. So quickly we will see those also. If you type I of 3, it will generate a 3 by 3 identity matrix. If you give ones of 3, it will generate a 3 by 3 ones matrix. If you type magic of 3, it will give 3 by 3 magic square. What is a magic square is, if you add all the row elements or all the diagonal elements or all the column elements, sum will be same. You can count here. The sum is 15, the sum is 15, the sum is 15, sum is 15. Here also sum is 15, and here also like this, it is sum is 15, it is sum is 15. So such a matrix is called as magic square. So it will simply generate you a magic square of n by n size in single click. So for understanding, I gave you small number. If you want, you can put a big number here, like 7 also you can give. It will give big magic square. Even you can add row wise, column wise, diagonal wise. Every addition is like unique value, same value you will get. Like what we have seen here, 15, 15, 15, like that. So diag, one more new command is diag of, so whatever the diagonal matrix you want to create. So I will copy that command directly from here. So if I type diag diag 1 2 3 column 0. So 1 2 3 are the diagonal elements. They will start from the 0th position. If I give 1 instead of 0 there, you can see diagonal matrix 1 2 3 is starting from first position. So if I put 3 from third position, 0 1 2 and 3, third position, here we have 1 2 3. So like that it will generate a diagonal matrix. And coming to the other operations, like flip LR. LR means right, left to right. UD means up, down, and then triangle L means lower triangle. Triangle TRIU means upper triangle. Size means it will return the size of the matrix. Inverse of a matrix. INV is the command. Rank of a matrix. EIG, eigenvalues of a matrix. So let us see quickly on all these also. So I am copying and simply pasting them here. So the input matrix for us is, we have a matrix generated. This is the matrix, 3 by 3 matrix, 1 2 3 4 5 6 7 8 9. So after typing this flip LR command on this matrix A, flip LR of A, you can observe here the middle elements. The middle column is as it is. One that was there on the right side is going left side, and from left side coming right side. So 369 came here, 147 came here. That is called flip left to right. Flip up down means this row will be constant, it will remain same, and this row will go there and that row will come here. You can see that here. 1 2 3 came down, 7 8 9 came, went upside. TRIUA, upper triangular matrix. So I am getting only the elements in the upper triangular. Lower elements are zeros. It is removing this 4 8 7. So lower elements become 0. Similarly, lower triangle, only the lower elements will be there, upper 3 elements are 0. Size of A, it's a 3 by 3 matrix. Inverse of A, so it is some precision error we got, but still answer is there. So it is showing, it is giving numbers with some different format. Rank of the matrix is 2, and eigenvalues of A, these are the eigenvalues of the matrix whatever we have created. So here also some numbers are in a different format. So system will give all the outputs for the different matrix operations. Rank, inverse will take much time to solve, but here I got in single click rank of a matrix, inverse of a matrix, and then eigenvalues of a matrix. Even magic square is not that easy to write, so system is giving in a single clicks. That's why I said this is a mathematical powerful calculator. You can implement all mathematics and all signals related operations in this software. So that is about the basic operations. The first experiment in our basic simulations lab playlist, basic operations and matrices we have seen just now. So instead of giving one by one command here, I wrote everything in editor program starting from the first command to the last, and I will write here clear, because if I won't clear the memory I will get a out of bound error. That means memory will not be sufficient if I won't write this clear command. So if you want, you can try, see that. So after clicking this, save and continuous run on this program matrices. So system, it is showing so many things are stored in the memory. So I will try to run again one more time, 3 times, 4 times, 5 times I run, because sometimes students will get confused and they will click this 4 5 6 even some 10 times. So they are thinking that system is not giving the output. I said output is available in command window, so go to the command window and check the output there in the command window. So here system is responding and it is giving the output for us. For every click that I did, it is giving me the output, but it is not clear exactly where our output is starting and what is where to read the output, all those things. So for that purpose, it is always advisable to type this CLC command. CLC will automatically clear the command window and give you the only current output. So this is the current output which I am supposed to read for my program, but still system is responding quickly here. In some of the systems, system will not show you the output if this memory is not sufficient. Memory will become insufficient and you will get an error, out of bound of memory error. So that indicates that the memory is not sufficient with the different variables which you are issuing in the program, and the data size is more. So it's better to type clear command here in the program. So it will clear the memory. You can observe here in this window, it is clearing the memory, and again the new data is coming which is related to the current program. So always we have to type those two. So by giving this command, and by clicking this I got all outputs. You can see starting from the row vector creations, and then operations, addition, subtraction, multiplication, element wise operations, sorting, whatever we have seen just now are all came in a single click. So that's the advantage of the editor. Instead of typing and checking for every line in the command window, type everything in the editor window and click this save and run, save file and run. You will get output in one click. So that is about how to work with Octave and how to program for the basic operations on matrices. So in the upcoming videos we will see how to generate signals and how to perform operations on the signals, and we will continue with all other operations also. Thank you for watching.